Okay, so welcome everyone to Unlock Physics Mathematics Class 10th. I'm your course instructor Parth and I would be providing you the NCERT solutions for the chapter that have been taught on our channel. So today we'd be looking at the NCERT solution of exercise 8.1 of chapter Introduction to Trigonometry. To watch the lectures of this chapter, you can refer to our channel. Now, under this series, we would be providing you solutions to all the questions in the NCERT. In this video, we would be looking at the solutions of lecture exercise 8.1 and in the upcoming videos of the further exercises and other chapters as well. So NCERT is a really good book if you are preparing for board examination because it works on the fundamentals of the concept involved. So it is better to understand the concept so that we can apply in the question as we want. So let us look at the first question that is given in our book on page 181, which says that in triangle ABC right angled at B, AB is given 24 centimeter, BC is 7 meter, but it's not meter, it would be 7 centimeter, and we have to determine what is sine A cos A, and in the second part we have to determine sine C and cos C. So in trigonometry we are talking about triangles. So for solving question, it would be very easy to solve the question if we draw the triangle in the first step only. So we have a triangle right angled at B and we have the values given AB as 24 and BC as 7. So we have to find sine of A, cos of A, sine of C and cos of C. So we have to solve for sine component of angle A and cos component of angle A, and in the second part we have to talk about the sine component of angle C and cos component of angle C. So using Pythagoras theorem in this triangle, we can find the length which is not given, which is AC. Applying Pythagoras theorem, we obtain AC square is equals to AB square plus BC square, which is 24 squared plus 7 squared, which is 576 plus 49, which is under root 625, which is 25 centimeters. So now we have AC given as 25, AB as 24 and BC as 7. So while solving the questions for trigonometry, it is important for us to keep in mind the trigonometric ratio table. So this table which you can see on your screen is a trigonometric ratio table, which would be referred as TR table in the coming videos. So TR table is very important. Now what does this trigonometric ratio table tells us? So there are some sine, cos, tan angles written in the first row, and in the last row we have cosec, sec, cot. We can see that sine is in the inverse of sine is cosec, inverse of cos is sec, and inverse of tan is cot. So we can see that there is some relation between them. There are also some variables p, h and b written in this. What do we say about this? So for reading this table, when we are reading the angles from the first row, then we read the table from top to bottom, and when we are reading the angles which is written in the last row, then we are reading the table from bottom to top. This is a division sign. So now we have the values, now we have the variables of the ratio, which says that sine is perpendicular upon hypotenuse, cos is base upon hypotenuse, tan is perpendicular upon base. We have cosec is hypotenuse upon perpendicular, sec as hypotenuse upon base, and cot as base upon perpendicular. So now the question is how to identify perpendicular, base and hypotenuse in a given triangle. So the angle which is opposite to the angle for which we are calculating the values, for example like sine A. Now for A, the side opposite to angle A would always be the perpendicular. So any side in front of this angle is always perpendicular. and side adjacent to that angle would be base. Now we have perpendicular, we have base, so obviously this will be our hypotenuse. Now these ratio don't work when we are talking about the right angle, because side in front of right angle will always be the hypotenuse. So these are some key rules which we have to remember. These are the fundamentals of trigonometry. So we have this ratio for the angles except for 90 degree. Okay, and these apply in a right angle triangle only. So now we have the formula, we have the values, and now we can apply them to solve our question. We have sin A. Sin A is P upon H, which is 7 by 24. So sin A is side opposite to angle A upon hypotenuse, which is the ratio given in the trigonometric table perpendicular upon H, which is BC upon AC, which is 7 by 25. Similarly, we have cos A given in the TR table as B upon H, that is base upon hypotenuse. So we have side adjacent to angle A upon hypotenuse, which is AB upon AC, which will be 24 upon 25. Now sin C. Now we were talking till now we were talking about angle A. Now we will talk about angle C. So when we are talking about angle C, then we'll have something different. The angle C will have this perpendicular in front of it. So this will be the perpendicular for angle C. This will be the hypotenuse because of the right angle, and this will be the base for angle C. For angle A, the side in front of the angle A would be perpendicular, and for angle C, the side in front of angle C would be the perpendicular. H will remain hypotenuse in both the case for AC, because it is in front of angle B, which is the right angle. So now we construct our triangle again, and now we have AC as our perpendicular, BC as our base, and AC as our hypotenuse. Again, we have the values, we have the formula, and we can apply them to find sin C, which is 24 by 25, and cos C, which is 7 by 25. So a lot of fundamental knowledge was needed to solve this question, and I'm sure that if we are good with trigonometric ratio table and forming a triangle and assigning the correct values, we would be easily solve this question. Now moving on to the next question, we have, in the given figure, find tan P minus cot R. So we have to find tan P, tan of angle P, and cot of angle R. Tan of angle P and cot of angle R. So we see that QR is not given. So applying the Pythagoras theorem, we can easily find QR, which would be 5 centimeter if we solve it. You can see 13 squared is equals to 12 squared plus QR square. QR square is equals to 25 centimeter square, and QR would be 5 centimeter. Now remembering our trigonometric ratio table, the TR table, we know that tan is perpendicular upon base and cot is base upon perpendicular. So now we have to mark our perpendicular, base, and hypotenuse for respective angle B and R. Now in this we mark tan of P. So this is P. So this side will be perpendicular, this side would be the hypotenuse, and this side will be the base. So which is perpendicular upon base, which is 5 upon 12. Now cot R. For cot R, we see this. So cot R. So the side in front of angle R would be our perpendicular. This will be our perpendicular. This will be our base, and this will be our hypotenuse. So cot R is base upon perpendicular, which is base upon perpendicular. So which is 5 upon 12 again. So now we can conclude that tan P minus cot R will be 5 by 12 minus 5 by 12, which is simply 0. Moving on to the next question, we have if sine A is given 3 by 4, we have to calculate cos A and tan A. So let us consider a triangle ABC, right angled at B. This is our triangle. And we'll make our trigonometric ratio table, which gives us the formula for the ratios of the angles. Now we see that it is given to us that sine A is equals to 3 by 4. Sine of A. So since we are talking about sine of A, so side in front of angle A would be the perpendicular. Side adjacent to A will be the base. And side in front of the right angle triangle would be the hypotenuse. So we see that sine A is equals to P upon H, which is BC upon AC, which is 3 by 4. Now we don't know that if 3 and 4 are the actual values of or the actual length of BC and AC. So we suppose that the value should be any positive integer, multiple of 3 by 4, because this is the ratio. So the actual value of BC and AC would be the multiple of 3 by 4. So let BC be 3k, we are multiplying k. So therefore AC will also be 4k, where k is a positive integer. Applying Pythagoras Theorem in triangle ABC, we obtain AC square is equals to AB square plus BC square, which is 4 squared is equals to AB squared plus 3k squared, which gives 16k squared minus 9k squared, and we finally compute AB to be root 7k. So now we have to find cos A and tan A. So cos A would be based upon hypotenuse, which is based upon hypotenuse. So that would be root 7 by 4, because this is root 7, this is 4, and this is 3. So we have cos A as root 7 by 4, tan A as root 3 by root 7. Cos A as base upon hypotenuse and tan A as perpendicular upon base, and then we have these values. Moving on to the next question, we are given that 15 cot A is equals to 8. Find sin A and sec A. Now consider a right angle triangle, right angled at B. Remembering our TR table, we consider cot A. So this is angle A. This will be our perpendicular, this will be our base, and this will be our hypotenuse. So cot is the ratio of, since we are evaluating the value of cot, so we'll read the table from down to up, bottom to up. So that is the ratio of perpendicular upon base upon perpendicular. So we have AB upon BC is given as cot A. It is given to us that cot A is equals to 8 by 15. How? Because 15 cot A is equals to 8. So cot A becomes 8 by 15. So now let AB be 8k. Therefore BC will be 15k, where k is a positive integer. Applying Pythagoras Theorem in triangle ABC, we obtain AC square is equals to AB square plus BC square. 8k squared plus 15k squared, which is 64k squared, plus 225k squared, which is 289k squared. So AC is under root 289k squared, which is 17k. Now we have to find sin A and sec A. We have computed all the values. So AC is 17k. We have AB as 8 given to us, and BC as 15 given to us. Now since we are talking about all the angle of A, all the components of A, so we don't need to move our angle. So we know sin A is equals to perpendicular upon hypotenuse, which would be BC upon AC, which would be 15k upon 17k, resulting in 15 by 17, and sec A would be hypotenuse upon base, which would be AC by BC, giving us 17 by 18. Moving on to the next question, question number 5, we have given that sec theta is equals to 13 by 12. We have to calculate all the other trigonometric ratios. So consider a right angle triangle ABC, right angled at point B. We assume that angle A is theta. Angle A is given to be theta. This is something that we assume to solve this question. Now again drawing our trigonometric ratio table, which is very important. So we are given sec theta. So for sec we'll read the table from bottom to up. So that is base upon hypotenuse. So for this angle theta, the side in front of the angle would be the perpendicular. This would be the base. This would be the base. And this would be the hypotenuse. Now sec theta is hypotenuse upon base, which would be 13 by 12, which is also AC by BC. AC by AB. Now AC is 13k, AB will be 12k, where k is some positive integer. Applying Pythagoras theorem in triangle ABC, we obtain AC square is equals to AB square plus BC square, which is 13k squared plus 12k squared plus BC square. 169k squared is equals to 144k square plus BC square. We compute BC to be 5k. Now we know that sine theta is perpendicular upon hypotenuse, cos theta is base upon hypotenuse, tan theta is perpendicular upon base, cosec theta is hypotenuse upon perpendicular, sec theta is hypotenuse upon base, and cot theta is base upon perpendicular. So we find all the other trigonometric values, we keep the values in these formulas, and we get the required desired value. So we have computed all the lengths of this right angle triangle. We keep them in each of these formulas and we get all the values, as you can see them on the screen. Moving on to the sixth question, we say that if angle A and angle B are acute angles such that cos of A is equals to cos of B, then show that angle A is equals to angle B. Now we construct a right angle triangle, right angled at D. CD is perpendicular to AB, dividing the triangle into be a two right angle triangle. Now cos A is given to be equal to cos B. It's given that cos A is equals to cos B. So from our trigonometric ratio table, we know what is given to us. So since this is angle A, this is angle B, so both the angles have one side in front of them, which is CD, so it would be perpendicular for both of them. This would be the hypotenuse for angle ADC, and this would be the hypotenuse for angle BDC, and this would be the base for both the right angle triangles. Now we have to prove angle A is equals to angle B. To prove this, let us extend AC to P such that BC is equals to CP. So we do a further construction in our triangle. We draw a line from B to P joining CP such that CB is equal to CP. Now from equation 1 we obtain that AB upon BD is equals to AC upon BC. So AD upon BC is equals to AC upon BC. So AD upon BD comes also equal to AC upon CP from this by construction that we have made. So by using the converse of BPT, we know that CD is parallel to BP. Now in triangle, angle ACD should be equal to angle CPB, corresponding angles, and angle BCD should be equal to angle CBP. So let us look at the angles that we are talking about. We know that side CD is parallel to BP. Side CD is parallel to BP. These two lines are parallel. So angle ACD, this angle would be equal to CPB, this angle. And angle BCD, that is this angle, would be equal to angle CBP, that is CBP. Okay. So now by construction we have BC is equals to CP, angle CBP is equals to angle CPB, angle opposite to equal side of the triangle. This gives us equation 5. So from equation 3, 4 and 5 we have angle ACD is equals to angle BCD as equation 6. In triangle CAD and triangle CBD, angle ACD is equals to angle BCD using equation 6. From angle CDA and CDB is 90 as given in the question. So therefore the remaining angles should also be equal, which are angle CAD is equals to angle CBD, which gives us angle A is equals to angle B. There's also an easy and alternative method to solve this. I would request all the students to tell me that solution in the comment section below. Moving on to the next question, we have question 7. Given that cot theta is 7 by 8, then we have to evaluate 1 plus sine theta into 1 minus sine theta upon 1 plus cos theta into 1 minus cos theta, and the second part of the question tells us to evaluate cot square theta. So second part is very easy, we will see that in a few minutes. Let us concentrate on the first part. So let us consider right angle triangle ABC right angled at B. This is our triangle. Now we assume theta to be at angle C. So if theta is our angle C, then this is our perpendicular, the side in front of it. Side adjacent to it would be the base, and the side in front of the right angle would always be the hypotenuse. So now this is given. We construct our TR table, which gives us the ratios. Now cot theta, cot will be base upon perpendicular, that is BC upon AB, which is 7 by 8 given in the question. Now if BC is 7k, then AB will be 8k, where k is a positive integer. Applying Pythagoras Theorem in triangle ABC, we obtain AC square is equals to AB square plus BC square. We further compute AC to be root of 113k. Using the Pythagoras Theorem, we compute AC to be root of 113k. So this is 113 under root. We have AB as 8 and we have BC as 7. Perfect. So now we have AC as 100 root 113. Now we know sine theta is equals to perpendicular upon hypotenuse. Cos theta is based upon hypotenuse. So keeping the values, we get sine theta is equals to AB by AC, which is 8 by root 113, and cos theta as BC by AC as 7 by root 113. Now the first part. Now let us solve this first part. So we solve for bracket, we multiply the numerator and denominator and solve it. So this gives us 1 minus sine square theta upon 1 minus cos square theta. We multiply 1 by 1 minus sine theta, then this and then this. Similarly we do for the denominator and we get 1 minus sine square theta is equals to upon 1 minus cos square theta. Now there could be a better way to solve this question from this, but we would be taking the easier way. There is one more smarter way which I would request all of you to tell me in the comment section how we can solve this. We can change this one into some identity and we can figure out what we are calculating. Now keeping the values, we know that sine theta is 8 by root 113 and cos theta is 7 by root 113. So keeping the values, we get 1 minus 64 by 113, 1 minus 49 by 113. Further calculating, we get 49 by 64. And in the second part, we have just asked to calculate cot square theta. Cot we have already given, so cot square theta would be square of cot theta, which is 7 by 8 whole square, which is 49 by 64. So we see that we get 49 by 64 in both the cases as of this and this. Now the question is, how would you convert this into cot square theta? So it is very simple. 1 minus sine square theta. We can convert 1 into sine square theta plus cos square theta minus sine square theta. Sine square theta gets cancelled and we are left with cos square theta. Upon we get sine square theta plus cos square theta minus cos square theta. Cos square theta gets cancelled and we are left with sine square theta. So here we are left with cos theta upon sine theta. Forgive me for my writing, please. And we have whole square for this. So we know that cos theta upon sine theta. If we further apply the values of trigonometric ratios, we get, and cos theta as base upon hypotenuse and sine theta as perpendicular upon hypotenuse. After solving, we get base upon perpendicular. After solving this, we get base upon perpendicular, which is nothing but cot. We have square of this, so we get cot square. So this was the other way that you could have used to solve this question, despite calculating sine and cos separate. Now seeing question number 8. 3 cot A is equals to 4. Check whether 1 minus tan square A upon 1 plus tan square A is equals to cos square A minus sine square A or not. This could be also done with the identities which you may have seen, but let us look at it by the traditional way. So we have, it is given that 3 cot A is equals to 4. So we have cot A is equals to 4 by 3. Now consider a right angled triangle ABC right angled at B. Remembering our trigonometric ratio table, we have angle A, so this will be our perpendicular, this will be our base, and this will be our hypotenuse. So we have cot A is equals to base upon perpendicular, which is AB upon BC, which is 4 by 3. Again, if AB is 4k, then BC will be 3k, where k is a positive integer. In triangle ABC, we have AC square is equals to AB square plus BC square. So we have 4k squared plus 3k squared. So we have AC is equals to 5k. AC is equals to 5k. Yeah. So now we know that AC is 5. We know that AB was 4. And we also know that BC is 3. These all form a Pythagorean triplet. Please study about it. What are Pythagorean triplets? Okay. So now we know the values, we know the formulas. So we have to just simply apply them. So we have found cos A, which is AB upon AC, which is 4 by 5. Sin A, which is BC upon AC, which is 3 by 5. And tan A, which is BC upon AB, which is 3 by 4. All from this table only. Let me explain it one more time, that if we are reading this table for the angles written in the first row, we take the top to bottom approach, and if we are talking about the angles written in the last row, then we take the bottom up approach. Obviously this is division, which you may have all guessed it by now. So now we have 1 minus tan square A upon 1 plus tan square A. So we keep the values 1 minus 3 by 4 whole squared upon 1 plus 3 by 4 whole squared, which is 7 by 16 upon 25 by 16, which is 7 by 25. Now we have to also find cos square A minus sine square A, which is 4 by 5 whole squared minus 3 by 5 whole squared, which is 16 by 25 minus 9 by 25, which is also equal to 7 by 25. So we can conclude that 1 minus tan square A upon 1 plus tan square A is equal to cos square A minus sine square A. So this is also an identity which you would be studying in the upcoming lectures. Moving on to the next question, we have in triangle ABC right angled at B, if tan A is equals to 1 by root 3, find the value of sine A cos C plus cos A sine C, and the second part we have to calculate cos A cos C minus sine A sine C. So let us consider a right angle triangle, right angled at B. We are talking about angle A and we are talking about angle C. So for angle A, we have perpendicular this, we have base this, and we have hypotenuse this, and for sine C, this becomes our perpendicular, this becomes our base, and hypotenuse remains the same. Remembering our trigonometric ratio table, we have tan A is equals to 1 by root 3, which is perpendicular upon base, which would be 1 by root 3. So if BC is k, then AB will be root 3k, where k is a positive integer. In triangle, we apply the Pythagoras Theorem. AC square is equals to AB square plus BC square. We get root 3k square plus k square, which is simply 4k square. So we get AC is equals to 2k. Now we know AC is 2. We know that BC is 1. And this is root of 3. So we have the values, we have the formula, and we have to just apply them. So sine A is equals to perpendicular upon hypotenuse, which is 1 by 2. Cos A would be base upon hypotenuse, which is root 3 by 2. Sine C would be root 3 by 2, because in sine C, if we construct something like this, we construct a triangle. This is right, this is C, this is A, this is B. So now this will become our perpendicular, this will become our base, and this will remain our hypotenuse. So we change the values. Sine C is again perpendicular upon hypotenuse, which is root 3 by 2. We have cos C as base upon hypotenuse, which would be 1 by 2. So now further we have sine A cos C plus cos A sine C. Well, let me erase this. So we have sine A cos C plus cos A sine C as 1 by 2 into 1 by 2 plus root 3 by 2 into root 3 by 2, which is 1 by 4 plus 3 by 4, which is 4 by 4, which is 1. We have cos A cos C minus sine A sine C as root 3 by 2 into 1 by 2 minus 1 by 2 into root 3 by 2, which is root 3 by 4 minus root 3 by 4, which is 0. So now moving to the next question, we have question number 10, which says in triangle PQR, right angled at Q, PR plus QR is equals to 25 centimeter and PQ is 5 centimeter. Determine the value of sine P, cos P and tan P. So we will construct a right angle triangle. We know that we have to determine the value of sine P, cos P and tan P. So angle P is important to us. Now it is given that PR plus QR is equals to 25 and PQ is 5. So let PR this be X. So this is X. Now QR will be 25 minus X. Applying Pythagoras theorem, we obtain that PR square is equals to PQ square plus QR square, which is X square is equals to 5 square plus 25 minus X square. X square is equals to 25 plus 625 plus X square minus 50X. So which gives 50X is equals to 650 and X is equals to 13. Therefore PR is 13 and QR is 12. So PR is 13 and QR is 12. We know that PQ is 5. Now for angle P, the side in front of angle would be the perpendicular as always. This would be the base and this would be the hypotenuse. Now we know that this is 13, this is 5 and this is 12. So we have our TR table, trigonometric ratio table with us. You have to read it from top to bottom because we are talking about sine, cos and tan. So sine P is perpendicular upon hypotenuse, that is 12 by 13. Cos P is base upon hypotenuse, which is 5 by 13. And tan P is perpendicular upon base, which is 12 by 5. So we have determined the value required. Moving on to the next question, question 11. State whether the following are true or false and justify your answer. So this is important. So the value of tan A is always less than 1. Sec A is 12 by 5 for some value of angle A. Cos A is abbreviation used for cosecant of angle A. Cot A is the product of cot and A. Sin theta is equals to 4 by 3 for some angle theta. Okay, so let us check the first question. Let us see. So consider triangle ABC right angled at B. Okay, since we are talking about angle A, so this will be our perpendicular, this will be our base, and this will be our hypotenuse. Considering our TR table reading from top to bottom, this is 5 and this is 12. So tan A is equals to perpendicular upon base, as you can see, which is 12 by 5. Now if we divide 12 by 5, we would get something around 2.4. Okay, 2.4. So 2.4 is greater than 1. Hence we know that 12 by 5 is greater than 1. So tan A is greater than 1. So tan A is less than 1 is not always true. Hence given statement is false. So this is false. Now looking at the second part, which is sec A is equals to 12 by 5 for some angle A. Now considering right angle triangle, since this is our angle, so this will be our perpendicular, this will be our base, and this will be our hypotenuse. Trigonometric table again. Sec is hypotenuse, since we are talking about sec, which is written in the last row, so we'll read the table from bottom to up. Sec is hypotenuse upon base. So we have AC upon AB is equals to 12 by 5. Yes. Now AC will be 12k, AB will be 5k, where k is some positive integer. Applying Pythagoras theorem in triangle ABC, we obtain AC square is equals to AB square plus BC square. So that is 12k whole square is equals to 5k whole square plus BC square. Now from here we read it till here, that is 144k square is equals to 25k square plus BC square, which is BC square is equals to 119k square. So BC is approximately 10.9k. It can be observed that for given two sides, AC is equals to 12k and AB is equals to 5k. BC should be such that AC minus AB should be less than BC, and AC plus AB should be greater than BC. So 12k minus 5k is 7k, and 12k plus 5k 17k. So we can see that BC should be greater than 7k and less than 17k. Our BC is 10.9k, which is in the given range. However, BC is 10.9k. So clearly such triangle is possible, and hence the value of sec A is possible. Hence the given statement is true. Moving on to the third part of this question. Cos A is the abbreviation used for cosecant of angle A. So we know that abbreviation used for cosecant of angle A is cosec A, and cos A is the abbreviation used for cosine of angle A. Hence the given statement is false. Looking at the fourth part of this question, this is fourth. So cot A is the product of cot NA. We know that this is absolutely rubbish. Cot A is not the product of cot NA. It is the cotangent of angle A. It is the cotangent of angle A. Hence the given statement is false. Seen the fifth part is sin theta is equals to 4 by 3 for some angle theta. So sin theta we all know in a right angle triangle is perpendicular upon hypotenuse from our trigonometric ratio table. So sin theta is equals to perpendicular upon hypotenuse. So in a right angle triangle, hypotenuse is always greater than the remaining two sides. Therefore such value of theta is not possible. Here we see that perpendicular is 4 and hypotenuse is 3. Hypotenuse square is always equals to perpendicular square plus base square. So sorry for my handwriting. So if hypotenuse is the sum of perpendicular square plus base square. Hypotenuse square is the sum of perpendicular square plus base square. So it can't be less than P or B. It has to be greater than P and B to satisfy this equation. Now answers for question 11 are false, true, false, false and false. I hope that's clear to you. Thank you students. That was all for exercise 8.1. Please like the video, share the video and subscribe to our channel. Don't forget to hit the bell icon. We'll be coming up with the next part of this video very soon. Till then, stay tuned. Thank you once again.